Chapter 7, 7.4 still, example 3. So here's the problem. There's the picture. So it says two sides of triangles have lengths of 15 meters and 20 meters. The angle between them is increasing at pi over 90 radians a second. How fast is the length of the third side? Oh, it keeps going. So I think it says changing. Okay. So this is basically our related rates section. Okay, so it's the what do I have, what do I need? Okay, that's what I really want you to start thinking about these terms. So what do we want? What are we solving for? X prime, good job. I'm solving for X prime. I want to know this rate of change. So it's X prime, good. So if I want to solve for X prime, then what do I need to do? Okay, you're on the right track. It's not Pythagorean theorem, it's not a right triangle. But I do, just think bigger picture. I need to relate something, right? I need to relate my sides and my x. So 2, I would say relate values is what you want to do. So in this case, which I'm not going to make you memorize this, if I wanted to use cosine law, I'd give you cosine law, but we're going to relate these with cosine law. That's how we're going to relate them. I'm not expecting you to memorize cos law. Okay, cos law is Math31. You get that cos law on your formula sheet. You'd get it on a test for me if that's what I wanted you to do. So I probably would say use cos law to relate them. So cos law, okay, would be x squared, because that's what I'm trying to find. 15 squared plus 20 squared minus 2 times 15, 20 cos of theta. That's cos law. So that's the cos law formula when you're trying to find a missing side. So are we okay? This is a formula. I can't do anything other than tell you that's a formula. Yeah, cosine theta. That's a theta there. Yeah. Because remember, it's cosine of the angle, and the angle we don't know. So it's theta. What's that? Yeah, that's not on there. Cosine law is not on your calc formula sheet. I'd put it in the question. If I said I want to use cosine law to relate these, I'd put it in the question. Okay? Yeah, is there anything besides the formula that's overwhelming you? So right now, we're just going to go ahead and combine things a bit, because we're going to take the derivative of this with respect to time. Because up here, it's radians a second. So you see radians second, you're thinking, I'm going to take a derivative essentially implicitly. I'm taking the respect of t, and I don't have any t's, which is where the x prime is going to come from. Yeah?
How do you, if you're taking the derivative of that, are you pretty much just taking the derivative of cos?
And the x. Yeah.
But everything else pretty much goes away?
Right, nothing for those two. Okay? So essentially, I'm just going to, can I just take the derivative from here? Are you okay with that? Okay, so if I take the derivative from here, it's 2x prime. Are we comfortable with that? Like Emily just said, the 15 and the 20, these guys are gone because they're constants. This right here is 40, 400, 600. Okay, so that's negative 600, but what's the derivative of cosine? Negative sign. So if I have negative 600 and a negative sign, I have a positive 600 sine. Now here's the part that you're going to go, You have to do, because normally inside it's just 1, but we have to take the inside, which is just theta prime. Is everybody okay? Are you mad, Logan? Be happy to help. I'm happy to help. I'm a math counselor in here. Okay, so this is where this was step 3. Now step 4, what I'd say is, what do we need? So we've taken the derivative, and we're going to solve for x prime. We're going to divide that over. What do we need? Yeah, we need to know what theta is. We need to know what x is. And we know what theta prime is. Exactly. I want to know what x is, I need to know what theta is, and I need to know what theta prime is. Do we know any of those from the beginning? So we know theta prime is pi over 90. That's just reading from the question. How about x? How about theta? What's that? Right? So we need x and theta, but they also give us, where is it? Oh, I think I cut off part of the question. Just a second. So yeah, sorry, cut off the question. That's not cool, but they give us theta. They want to know at pi over 3 is where they want to know. So this is what you have to do. Pi over 3, okay, at pi over 3, what's our x value at pi over 3? Correct. But that's the degrees, though. So we're trying to figure out at pi over 3. So we're going to essentially, so you're right, 60 here. Okay, so we put 60 in here, then we can get x in terms of the cosine law. So if I know this is 60 at pi over 3, that's 60 degrees. I can now use the cosine law. Like I can use this, and I know what that is. That's 60. Okay? So when you do that, do you want me to do that work? Yeah, okay, all right. So then this right here, let's do that on a separate piece of paper. 625 is what these are added together. Okay, this right here, that's 600 cosine. Oh, wow, 600 cosine. 600 cosine of pi over 3, which we said is 60. We'll change to 60 if you want to stay in degree mode. So that's what we have right here. Cosine of 60 that I'm trying to get to you in your unit circle is up here. That means for cosine, it's the smaller one. So it's 1/2. You can do that on your calculator. If you don't know what cosine 60 is, it'll tell you 0.5. It's fine. Okay? But this is 1/2. So then we have x squared, 625. Half of 600 is 300. X squared, 325. Square root. X equals, that's 25 times, I think I got 13. So 5 root 13 is what x is. Now we have everything we need. We just need to plug it all in now. So that was all the work. Okay. Questions on anything if I lost you? Again, that's cosine law. Don't have to memorize it. You should be able to solve for x in that situation, though. You're in calc, you can do that. Okay. So I'm here. So the last thing I'm going to do, I'm going to divide the 2x over, which is going to give me, I'm going to go ahead 600 divided by 2. So that's going to be 300 sine theta prime all over x. And now we enter these three things into all of those three things. So x prime is 300 sine our theta is pi over 3, or you can put 60, doesn't matter. Our theta is pi over 90. Remember, this is like separate. And then all over 5 root 13. Okay, and when you calculate that, gives you 0.5 meters per second. So you punch that in, you should get 0.50 meters per second. So this is changing 0.5 meters per second. Okay, I'll pause there for a second, see if you want to ask questions. Okay, so here's example 4. More applied, more of a picture. Okay, a little bit different. Okay, so you have a beacon located perpendicular distance of 315 from point R. So you have a beacon like a lighthouse looks like or some sort. But there's a shore point R on a straight shoreline. It revolves 1 revolution a minute. We'll talk about that. That's a little bit of a curveball, but we'll come back to that. How fast does its beam sweep along the shoreline at point S on the shoreline 425 from R? Okay, so it wants to know this thing's coming like it's just going like this. Okay, and it wants to know when it hits S, how fast is it hitting S in terms of the light. Okay, so light travels rather quickly, so this is going to be, I would expect something pretty quick. Okay, all right, so question 1, what do we need? Or what do we want? What do we want? How fast does the beam sweep along the shoreline from S to R? Close. So this doesn't represent speed, though. That's the angle of the light. This would be the speed of the light. So x prime again. Does that make sense? Because as the light travels in x, it's going to be doing a speed. And so this speed will be represented here, like 25 meters a second. So we want x prime. Okay. How can we relate the values to implicitly take the derivative and get an x prime? What's that? Pythagorean Theorem. I'm trying to think if you could. I don't want to stray away from what my notes have just in case. Pythagorean Theorem. So the problem with Pythagorean Theorem is that we know for the specific time point that we're looking for, but in order to relate it, we're going to have to relate it without, because technically, if this is changing, then we don't know this either. So we have 2 kind of blanks with Pythagorean Theorem, which makes that a little bit tough. So we want to actually think about something we're only using 2 sides. So what's a way in triangles we relate just 2 sides? And think about what unit we're in. What's that? Tangent, exactly. Trigonometry. So I'm going to do tan x over 315 to relate my x to the changing side. So tan theta equals x over 315. So then we'll multiply the 315 over, and it's actually set up kind of nicely. It's going to be 315 tan theta is x. And now we can take the derivative. There's 2 ways. I actually got it right, and I went a different way than the notes in the book, so I'll see what you guys want to do, or what your intuition says to do here. But we'll take the derivative first. So that's x prime. Cool. That's going to be, what's the derivative of tan? In the sheet there, secant squared, right? And then don't forget theta prime. We need the theta prime there. Okay, we have x prime by itself now. What do we want? Or excuse me, we have what we want. What do we need from here? So we don't need an x, right? We need a theta and a theta prime, okay? Okay, theta prime is actually given. It's the 1 revolutions a minute. However, what does that mean? 1 revolution a minute. Yeah. All the way around, and great, Jared. So then if every minute goes all the way around, what is that value? Good. Give it to me in radians, though. 2 pi. Good job. So this is 2 pi, 1 revolution. 1 revolution means 1 time around the circle, 2 pi. Right? From your unit circle, 0 to 2 pi. Okay, good. How do we get theta? How do we know what the angle is? What's one number we haven't used yet? 425. 425 is the specific time point we want to know the speed, so we want to use that. So this is like essentially when I say at a certain x value after your derivative, I want you to do it, like tell me what it is. So we plug the x in to get the y, right? It's the same exact thing. 425 is the value here. What angle gives me that? So how can I figure that out? How would you figure that out? There's 2 ways. They did a weird, like a little bit weird way. I thought I did an easier way, I think. So how would you solve for theta? If we're trying to figure out what theta is, we're just solving for theta at 315 and 425. Yeah. Yeah. Right. You put 425 over x's and then do what? Yeah, tan. We're just going to go tan. That's what I did. We're going to go tan theta is 425 over 315 and just inverse tan. That'll give us a theta value. That theta value in your degree mode represents the degrees. So I got 53.4. Make sure you're in degree mode in your calculator if you do that. If not, you'll be in radians, which is still fine. Just stay in one or the other. Okay. Now theta, if you're in degree mode, like it doesn't matter. This is a revolution is a radian measure. So what I'm saying is if I'm in degree mode, like somebody asked me last year, I remember they said, how come you can put 2 pi in for this, but then 53 for this? Well, because if I'm in degree mode with my calculator, it only applies to the trigonometry one. So the 2 pi is a value. Does that make sense? Okay, so don't be confused there. So then now we're done. We just plug all this stuff in. So we're right here. Okay, so we're going to go 315. In your calculator, you can put secant 53.4 squared 2 pi. 1 over cosine. Yep, 1 over cosine. Good point. I have that in my notes. 1 over cosine. When you calculate that, you should get the same thing as the book, 5580. Yes? Mm-hmm. Right. So, what you gotta understand is this only messes you up in degree mode if you're doing a tangent of 2 pi or a cosine of 2 pi. But if you're putting 2 pi on the outside, you can't put 360 on the outside because your calculator won't count that as a degree. It only counts degrees of things that are actually in a trigonomic value. So if you put 360, that's 360 to it, not 6.24. So yeah, it's going to throw everything off. And so essentially what I'm telling you is, because go back to this, Emma, like the formula for circumference is what? 2 pi r. Have you ever seen it be 360 r? Right? And so it's because the degree only comes within the trigonomic values. So 2 pi represents a revolution of a circle. Right. What I'm saying is, but you can do everything in radians because radians won't affect it. If you do radian mode, 2 pi will still be 2 pi, so it'll be fine. And then what you would put in here, you'd have to figure out what 53 degrees is radians. So you have to do that conversions we learned in chapter 6 briefly. But you just can't put in 360, no. Okay? All right. Any other questions? That's the last one. Okay? All right. Good.